Okay, hi everyone. These presentations always start off with the usual disclaimer. Clearly I'm showing you all this stuff for testing and not to take over the world's major crimes, minor crimes or whatever. Brief agenda, we're just going in a typically recursive way. You're looking at my intro in the intro there, and a bit of a who am I. Go through a quick overview of Salesforce. How many people in here are already familiar with it? Okay, and then Salesforce overview for anyone not familiar with it. Quick overview of the SOSL'ed language. Quick overview of how the intro works. And then we'll go through finding injection vulnerabilities by code review and application testing. Just slightly more interesting, exploiting what you found. And then mitigations and defenses, because we're all responsible people. Quick split on how many red teamers here, or offensive, and how many blue team or defensive people. And then finally, conclusions. So I'm basically some guy who started off developing secure software in the financial sector, doing some secure software developments. Okay, something's gone horribly wrong. Right, as I said, started off in secure software development, which turned out to be a good grounding for moving into security consultancy, where I sort of moved on to a lot more code review, application testing, threat modeling, which is something I'm still working on today, which is how I initially came across this issue. Right, just to be clear on what the talk is and isn't about, this is about a vulnerability that's present in Apex codes. So it found in customizations and extensions built on top of Salesforce. And it's just going to show you how to locate that in other people's custom codes, how to exploit it or go about testing it. And it's partly happening because when I first came across the issue, I could not find any payloads online anywhere, no tutorials, and so had to go through the horrifying experience of doing my own research and writing it up. It is not a talk about Salesforce, and this vulnerability, just to be clear, it's something to be found in extensions built on top of Salesforce, APIs talking to Salesforce. There will be no 0 days here. And on the subject of Salesforce, I am not a Salesforce expert. I'll happily answer the SOSL'ed questions, but if anyone asks Salesforce questions, I'll try to answer, but I might look confused while doing so. Having just told you I'm not an expert on Salesforce, I'm going to patronisingly explain to you what Salesforce is. It's a CRM system, and it has a couple of things called sites and lightning apps that allow users to build extensions and apps on top of that. And it has these records incorporated into it which use this CRUD way of applying permissions any user with access to records will have create, read, update or delete permissions, but those permissions can vary across users, which again is why the injection issue can become important, as we'll see later. And it does look like this, but usually a lot more polished, because that's my thing that I did with Salesforce free development thing. You can use a free developer version to play around and learn more. But you will be limited to a very small number of users on that, which can hinder attempting to sort of play around with user permissions and any exploitation that depends on user permissions. I've just mentioned the create, read, update, delete stuff. That applies to Salesforce objects, which are the things manipulated by different Salesforce languages. SOSL'ed is only one of those languages. The best conceptual way, I think, of looking at the objects as a bit like spreadsheets, where fields can kind of relate to the columns in the spreadsheet, records to the rows, and the objects are like the table or a sheet of that metaphorical spreadsheet. And as I said, different users may have access to different fields within those objects. Now, the data handling, the languages I've just been talking about, rather than just using SQL, Salesforce has this Apex language derived from Java, which, if anyone's ever used Java, Apex will look very familiar to you. Comparatively easy to read. It's a lot like Java to build APIs that interact with Salesforce, custom components on top of Salesforce. SOSL'ed is virtually the same as SQL or SQL, but only interacts from Salesforce with Salesforce data and only does queries. DML, again, very similar to SQL or SQL, but that only does modifications and deletion of the objects. SOSL'ed is a query language that has quite a sort of different syntax to SOSL'ed, and it gets used in different circumstances, and it is specific to Salesforce like the other three, so you won't see it anywhere else. And that stands for Salesforce Object Search Language, and it generally gets used to search through your collection of objects that you have in your Salesforce implementation. And the Salesforce website's great because it's filled with tutorials and other details. It gives these reasons why you might use one and not the other. SOSL'ed is used in very similar circumstances to SQL, where you've got a really specific idea of what you're searching for, and you'd build up a select statement knowing which fields you're looking through, which tables you're looking through. SOSL'ed is a bit more free and easy in its searching abilities. It will literally search everything that user has permission to see. You can use the syntax to narrow down those searches. But when you see it, it looks like a bit like this. This is stuff, again, taken from the Salesforce tutorials. So as I've said there, like if you're a C programmer, the first time you see Java, there's enough familiarity for it to kind of make sense and enough differences for it to be immensely confusing. But basically it has these sort of constructions. The find keyword is always present, and then it has these number of other optional fields after where you can search different groups or fields and return different objects from Salesforce. And that thing right at the bottom there, that's what it looks like when it's used within Apex code or called from Apex code. SOSL injection, as I've heavily hinted, it's an accepted known vulnerability type that you will find in Apex code where someone's built up dynamic queries of the type we've just seen, but with poorly validated inputs or with not a lot of forethought as to what can go wrong. There are information disclosure issues, but it's almost impossible to get any sort of real disaster built upon that unless someone's done something weird in Apex, like a mass mailing based on a SOSL query or some other spammy kind of thing like that. And the Salesforce information page, you can read faster than I can talk, so I'm not going to read all that out, does give that definitive view on what SOSL injection is. Basically a repeat of everything I've just said, that unsafely constructed Apex queries can result in this SOSL injection issue. From seeing the Salesforce description, you're probably wondering, how can I find out more, like I did? And the first answer to that is that you can't. When I initially looked for issues around this or for payloads I could use, write-ups on how to exploit it, I found, I guess, that description on the previous slide was the longest write-up I could find. I found one website that told me it exists, and no real kind of stuff that I could use for the testing I was doing. So, what we'll go through is there's 3 ways of finding this. You can find it by code review. You might find it in web application testing, and far more likely to find it API testing than web app testing. The Salesforce Lightning apps and sites stuff that I've talked about earlier is a no-code or low-code way to build websites. There's a lot of stuff in there to stop people from shooting themselves in the foot, and it's almost impossible to mistakenly create SOSL injection that way. But we'd go through, for each of those, go through a fairly standard kind of hacking methodology that you're probably all familiar with, of the initial footprinting and outlining of the issue, and then a bit of further testing to look at sanitization, how easy is it to inject and how exploitable things are. As I say, in this case, because of the CRUD sort of permissions, the exploitability is going to be information disclosure, but for a user being able to see records that should have been hidden from them. So SOSL code review, you will be carrying it out in Apex or in Java. I've come across a few times Java code that interacts with Salesforce. there's the standard advice that we saw on the Salesforce website is to always use escape single quotes, which I think not everyone does from some of the code I've seen. But you can also build up the SOSL this way for Java code. For anyone looking at those two and not initially seeing the difference, which is understandable, the Apex code has that single quotes around the search string, and the Java code has the curly braces around the search string. But the syntax is very simple. It's a lot simpler than SQL. The code will always start with the find statements. And so that will be present for any SOSL query. So it's reasonably easy to grep for that on that basis. So for you can use like a nice sort of, well, there's no such thing as a simple regex, but it's a bit of a dark art, but I think, find, it's important. This is not, it's not a case-sensitive language. It's generally written in capitals the same way people always write select in capitals for SQL. But it can be both cases. So those two regexes at the bottom, there might be other correct versions that are available, but those two will find the boundary of the word find, case insensitive, followed by 0 or more spaces, and followed by single quotes or curly brace, which should allow you to enumerate a full list of those instances from the code. From that point, you have a full set of results that you can start looking for injectability and the more important thing about user permissions from. Finding this in an app test, you might find a number of search things within an API or the web app test, and it's not immediately apparent which one's a SOSL and which one's a SOCL. These payloads here are the ones that I accidentally discovered how to enumerate with. Those three there, and well, 4 when used. For the first 3, you'll always get the same error message. That would indicate that the search API or the web application that you're testing is using SOSL and not SOCL. And just to explain, it says you must have 2 or more characters, even if you've put A asterisk or A asterisk in quotes. That's because SOSL generally puts things in, allows you to put the double quotes around separate search terms within the find category, and also demands, it says 2 or more characters, it means 2 or more non-wildcard characters. So those would all bring back a perfectly working search for SOCL, but not for SOSL. And for the 4th one, you would get a set of results. In the web application, it looks like that top one there. That's what a failed search looked like for my sort of homemade Salesforce developer test. And for the API, you will get a HTTP 500 error if you do this, which again massively speeds up the enumeration if you're using those payloads for fuzzing. And the successful search would look like that, of either successful search results or a list of a bit of a response from Salesforce explaining that that search term wasn't found. You can use a few other values that will again help in enumerating these SOSL or SOCL kind of things. Things there would be errors in SOCL from their weird construction. But that double quotes around known good, whatever your value is, or some other value, is a valid construction to fit inside the curly braces or the single quotes of the find statements. That's obviously not so good for some fuzzing payloads because they depend on you knowing the known good and known bad values. But these are massively more useful when investigating the exploitation possibilities and the information disclosure stuff. And just when you do come to investigate these, you will frequently find for a lot of Salesforce stuff, it's a single sort of database. All users will have varying levels of access. It's generally much more of an issue in APIs than web applications, as I said earlier, because the web building interface just really prevents people from doing anything too silly or too unsafe. The web API also, it does kind of restrict the web application itself. That restricts searches to data allowed for your user. The APIs are generally written in Apex. They will generally run in Salesforce as two modes, system mode and user mode. So the data visible to an API running in system mode will be everything, which is where the information disclosure comes in. Every sort of object will be searched by the API written in system mode. An API search in user mode will bring back exactly the same as doing a similar search for the web interface. When it does come to exploitation attempts, one of the, I guess, real serious difficulties, SOCL and SOSL'ed don't have a comment character, so you can't treat it like SQL injection and then just cut off the rest of the statements afterwards. It doesn't have any data modification constructs, and there's a much more restricted syntax. You can't interact with the OS in the way you can in PL SQL or T SQL. So chiefly, like when we do have those, moving on to that next stage of that methodology, when we've built up that list of code review kind of findings, we'd have to go through those looking for what would seem to be a level of exploitability. The dynamics SOSL statements will generally look like this, with the single quotes and the plus signs surrounding the user supplied values. One sort of thing that I've just been inferring earlier from the APIs, I appreciate that's very small and hard to read up there, but the search on all fields, according to the Salesforce website here, the search through all fields runs as running in system mode will return values that a user does not normally have access to. It ignores those CRUD permissions when searching all fields. To look at how you can sort of identify this from a code review perspective, that is an extremely contrived example there. But if this was some search situation where the user's supplying a string such as their search criteria of name, email, phone number, and selecting what they want from a drop-down list of name, email, phone, that despite the use of the escape single quotes would be vulnerable to I guess a weird sort of quirk of SOSL injection, which has these different in clauses and different fields can be specified. As we saw from the earlier slide, that all fields ignores the user permissions when it searches. So one way that could be written up as an exploitable code issue would be that from comparing the two examples there, the normal usage would return whatever email you're searching for wherever it's found in email fields. The exploited version lower down would literally search ignoring user permissions across all objects within that Salesforce tenancy or implementation. An usual sort of thing I would say about code review, do check what's done afterwards. If that SOSL search has been used to modify records or to generate mass email or mass mailings for people, then obviously the seriousness of that is raised as well. In terms of user mode versus system mode that we've just talked about, as I said, default Apex runs in system mode and will search everything, but you can enforce user mode could have been enforced by the developers. So do check that as well as part of your code review. In terms of investigating for your app test results a bit more thoroughly, it can all be done, I guess, with generally the simplest bare bones of web app tester tools. And just move on from your initial footprinting to test those endpoints you've found that did appear to be SOSL endpoints. The initial tests that you will need to do from this would be to check for the sanitization, check what happens with curly braces or single quotes being put through those. If there's been any escaping of those or sanitization by the developers, you will get no error. It will just behave like it's searched for the objects for a single quote or for a curly brace. What you are looking for really is for any fields or data that have been exposed that shouldn't have been. And in terms of the application testing, it's good to test the APIs and web interface at the same time. You can look at how the search differs across the two. For like an API response, you would, this is obviously a fictitious fruit searching API, not any real clients kind of thing. But successful search results for that kind of SOSL payload would bring back the query results like that. So that API doesn't appear to bother about you messing around with those kind of SOSL constructs within there, and brings back various data that satisfies the search criteria. If we were doing this as an API test alongside the web app test, then we might try running that through the web app as well to see what results come back. I will just show you something. This isn't going to work because I've got no web connectivity. I will go back to just showing you that page without bothering to try and get connectivity and demonstrate it. But as a default, your Salesforce web app page will always have this completely safe, I should add, SOSL search that's right at the top there. And that's something you can always use to test the API results as compared to the web app results to see if you're getting anything back that you really shouldn't. So you might see something like the code review example from earlier can be sort of inferred if you have fields that look like that. And that again is some injectable points. Besides this stuff like the find and fields, there are other clauses within Salesforce. There is a Salesforce SOSL syntax page that gives you the really sort of constrained and narrow syntax of the language, where you can find stuff like this. So it has a returning clause, which, again, you might find that dynamic code's been constructed around this where clause, which looks like this. So using the returning with a where clause, it can have some additional search values within there, which again could be injectable depending on sanitization. I appreciate the language might look a bit weird for anyone who hasn't seen it before. But that could be, if that's not sanitized, that on the example query there, if not sanitized, could be exploited in the way you might be familiar with SQL injection, where you just match up your own opening and closing single quotes. From that previous page, you might have thought there's a lot of, I guess it might have looked a bit impossible to construct that because you might not know what the objects are, but the Salesforce implementation has a large number of standard objects, which you can look through and use those to build up that kind of thing we had on the previous page. So any sort of other objects that you might want to try can be found by just reading the standard documentation. Now, since we know there's blue team people in the room, and for offensive people, our job is to give recommendations after we've broken this stuff. So there are mitigations that you can have around the sort of things I've been showing. Queries can be executed in user mode, which you can do. For sometimes that might not be desirable, but for instance, if somebody wants to search the entire sales or has to look through all customer complaints, that might have to run in system mode, just because that's the only way for them to see all of those records created by other users. But yeah, user mode, wherever possible, massively reduces the risk of information disclosure. Although I've been discussing a lot of this dynamic stuff with inserting user searchable things within single quotes, there is a colon operator that you can put before variable names instead of doing all the close quotes and plus sign stuff to build up queries in a much safer way. The last one at the bottom, like I guess that avoiding direct use of user-controlled string literals, again, always a really effective thing. The deliberately contrived thing I showed you where you could have searched for email, name, or whatever fields could have just been prevented with a drop-down list that mapped numbers on the server side onto allowed fields. So like some examples, safer statement construction there, you would either you would either escape single quotes or use that double quote operator that I've just mentioned. And again, same thing there. That's proper input validation, but that final thing at the end, that is how you would apply user mode to a search so that it only searches objects that are readable or modifiable by that user. Okay, that's covered a lot of the SOSL stuff. The payloads for SOSL are quite different, as you've seen from SQL injection. I'm really doing this talk because normal payloads in my fuzzer didn't find it, but so I thought other people should have some workable payloads. For SQL injection, payloads should identify SOSL injection, so much less of a need for that sort of discussion here. So just brief conclusion. As I said, you can read faster than I can talk, but yeah, we've seen it's an information disclosure issue. The main issue here is whether or not somebody can see hidden data that they shouldn't be allowed to. It's quite counterintuitive for anyone used to SQL injection because rather than being some user injectable thing in the select statement, it can be stuff towards the end of the statement in other parts can be quite sort of much more useful than what you might class as a useful injection point in SQL injection. But I guess the other sort of thing to take away from this is around user permissions and what is requirable by the client or person running that instance. It's not an issue if all users should be able to see more data, but this is what I've achieved in like a short space of time. It's only, I guess, an introduction to the subject and based on my experimentation. So if anyone wants to do more research based on that, and I hope this is a suitable starting point. Are there any questions? Yeah.
Can we have a first round of applause first for Nick?
Yes.
Thank you. That was a nice talk. I just wanted to ask that one, if there is any automated tool like SQL Map, that automates the process of exploitation of this vulnerability that you have described, social injections and other injection. The other point is about the use of colon, which you described as much safer than the function. So what could be the possible reasons, reason that, the colon function is much more safer than, the escaping functions and sanitization functions? Thank you.
I guess it's kind of safely sanitizes what's being imported into that statement in the way you might have seen it in the way some languages like C#, if you've seen the way that builds safer dynamic SQL statements, they are sort of sanitized before being used there by the system.
So is it the equivalent of, I would say, the parameterized queries in SQL?
Yes.
Okay. Exactly. Yeah, now I get it. Thank you. And in terms of the automated tool for exploitation of these issues, is there any tool that automates the process of exploitation?
I didn't find anything. I've done the talk because I found nothing online at all.
Okay. Thank you.
Thank you. So within your talk, you described as an example somebody being able to select the description of secret contract or something like that, trying to pull information. Is there anything that tends to exist by default which would be of interest to an attacker that they could regularly pull out, potentially?
This would probably be a good time to go back to the I'm not a Salesforce experts slide.
How prevalent is this vulnerability in your experience? Is it in every application using SOSL, or is it pretty rare?
I'll caveat this by saying the number of SOSL applications I've come across and tested has been single figures, not double figures. There's been, I guess, it's been there in all of them, but with that level of seriousness caveat that a lot of these implementations, all users were allowed to see all data anyway. So although there were no fixes in place, there was also no damage being done. The real thing that came out of it was, I think, the lack of awareness of it means, for egotistical purposes, you can find issues that weren't found on previous tests, or that other people have missed or that haven't been fixed. It's certainly something it's been met with confusion every time I've raised it when I have found it. But a lot of the time it's been found in a really non-serious kind of way. I know that's not the best, sort of most helpful answer, but.
Maybe just one question from my side. Are you aware whether any application code scanning tools would pick that up? Is it in scope?
I've been told that some commercial tools will search for it or locate it. I think I saw someone online saying check marks will find it. I don't know if that's true, but I'd also be interested to know how they went about defining how to find it, because there's, I guess, so little information about the issue.
Okay, if there are no more questions, thank you very much, Nick, and a big round of applause to you.